Welcome to Cosmic Compass, where we explore the wonders of the universe together. Out here, every planet, every star, and every mystery in space has a story to tell. Our goal is to guide you through those stories, sometimes familiar, sometimes surprising, but always fascinating. Today we're turning our attention to the Hubble Space Telescope. For decades, it has been our silent observer in orbit, showing us not just distant galaxies, but also incredible moments within our own solar system. From cosmic collisions to planetary storms, let's uncover the hidden drama Hubble has captured close to home. For nearly 3 decades, the Hubble Space Telescope has been humanity's window into the universe. It was originally designed to peer into the depths of space galaxies, nebulae, and the farthest corners of the cosmos. But along the way, Hubble turned its gaze a little closer to home. It looked at the worlds of our own solar system, capturing rare events and remarkable views we might have otherwise missed. Not every planet or moon has its own dedicated spacecraft. Missions are expensive, they take decades to plan, and many worlds remain unvisited. That's where Hubble steps in. Even though it wasn't built for solar system observation, its keen eye has given us extraordinary snapshots that help fill in the gaps. So today, let's journey through some of the most unforgettable solar system moments seen by Hubble. From asteroids breaking apart, to a comet slamming into Jupiter, to Saturn's great storms, these images are not just photographs, they are stories of cosmic drama unfolding in real time. At first glance, you might think you're looking at a comet, a bright streak in space with not just one but 2 tails streaming behind it. But this isn't a comet at all, it's an asteroid, specifically asteroid 6478 Gault, only about 3.5 kilometers wide, residing in the asteroid belt. So why does it have a tail? The answer lies in a subtle but powerful effect called the Yorp effect. Radiation from the sun, when hitting an irregularly shaped object, can cause it to gradually spin faster and faster over millions of years. In Gault's case, that spin has accelerated to the breaking point, 1 full rotation every 2 hours. That's right on the edge of what an asteroid can withstand. Centrifugal forces are now overcoming Gault's own gravity, flinging dust and loose rubble into space. Over time, this process will continue until the asteroid can no longer hold itself together. Eventually, it may disintegrate completely, scattering its remains into space. This reminds us that most asteroids and comets are not solid boulders, but fragile piles of rubble, barely held together by their own gravity. And here, thanks to Hubble, we've caught one in the act of tearing itself apart. Now let's move from a small asteroid to one of the most dramatic cosmic collisions ever witnessed. In July 1994, a comet named Shoemaker-Levy 9 crashed into Jupiter. Jupiter is often called the solar system's vacuum cleaner, and for good reason. With a mass equal to nearly 3/4 of all the planets combined, its gravitational influence is immense. Objects wandering too close are often captured, redirected, or destroyed. That's exactly what happened to Shoemaker-Levy 9. About 20 years before its final plunge, the comet was trapped by Jupiter's gravity and forced into orbit around the giant planet. But its orbit brought it dangerously close. Tidal forces ripped the comet into multiple fragments, setting the stage for a collision unlike anything humanity had ever seen. When those fragments finally slammed into Jupiter, the impacts were catastrophic. Fireballs rose 3,000 kilometers above the planet's clouds, with temperatures soaring above 23,000 degrees Celsius. The largest scar left behind stretched over 12,000 kilometers across roughly the size of Earth. The energy released was equivalent to 6 million megatons of TNT, over 600 times the combined nuclear arsenal of Earth. Imagine watching that in real time, knowing we were witnessing history unfold on another world. For scientists, this was the first direct observation of an extraterrestrial collision. For the rest of us, it was a reminder of the raw power of the cosmos and perhaps of Jupiter's role as a shield sweeping up objects that might otherwise head toward the inner planets, including Earth. At first you might wonder why Hubble would spend time looking at the moon. After all, we have spacecraft far better suited to lunar observation like NASA's Lunar Reconnaissance Orbiter. But in 2012, something unusual happened. Venus was passing in front of the Sun, a rare alignment known as a transit. Scientists had an idea. What if they used the moon as a giant mirror? Hubble cannot look directly at the Sun. It's simply too bright, but it can look at sunlight reflected off the moon's surface. And during this transit, that sunlight had already passed through Venus's thick atmosphere. By studying subtle variations in the reflected light, astronomers could test a powerful technique determining the chemical composition of a planet's atmosphere from afar. We already know Venus's atmosphere is dominated by carbon dioxide with clouds of sulfuric acid, so this served as a perfect experiment. Why does this matter? Because this is the same method used to study exoplanets orbiting distant stars. When a planet passes in front of its star, light filters through its atmosphere. By breaking that light apart, scientists can detect gases like oxygen water vapor or methane, possible signs of life. So in a sense, the moon became a tool for practicing how to search for life across the galaxy. It's a reminder that sometimes even the most familiar worlds still have a role to play in our greatest discoveries. Hubble has often turned its gaze toward Mars, providing a global perspective that even orbiting spacecraft cannot always capture. Its images reveal dust storms sweeping across the surface, seasonal changes in the polar caps, and the shifting weather patterns of a planet that fascinates us more than almost any other. One Hubble time-lapse shows a global dust storm engulfing nearly the entire planet. To the human eye, on the ground, such a storm would darken the sky for weeks, turning daylight into a dim red haze. But Mars isn't the only star of the show. In the background of Hubble's images, we see the planet's two tiny moons, Phobos and Deimos, zipping quickly across the sky. And they really do zip Phobos, the larger and closer of the two orbits Mars, once every 7.5 hours. That's faster than a Martian day itself. From the Martian surface, Phobos would rise in the west and set in the east, racing overhead multiple times each day. Hubble's time-lapse brings that frantic dance to life, reminding us just how alien and dynamic Mars really is. When the Cassini spacecraft ended its mission in 2017, Saturn lost its closest observer, but Hubble has been there to continue the watch. Saturn is a planet of breathtaking beauty, and Hubble's images keep us connected to it from afar. The telescope regularly monitors Saturn's weather, tracking vast storms that can span thousands of kilometres. It also helps fill in data about seasonal changes, important because Cassini only witnessed half a Saturnian year during its time there. Some of the storms Hubble has recorded are larger than Earth itself. To imagine an entire world wrapped in a storm that could swallow our planet is staggering, and yet Hubble captures these events as if they were passing clouds. Beyond the science, these images remind us of the sheer wonder of Saturn's rings and moons. They are visual treasures, snapshots of a system that even without Cassini continues to inspire awe thanks to Hubble's watchful eye. Finally, let's look at something extraordinarily rare, two asteroids colliding. In 2010, Hubble imaged an object that looked at first like a comet, but closer inspection revealed something stranger. The central structure wasn't a normal cometary nucleus. Instead, it showed a bizarre X-shaped pattern of debris. What we were seeing was the aftermath of a collision between two small asteroids. The X-shaped filaments were streams of rubble flung into space in different directions. Some particles drifted back toward the center, pulled in by weak gravity. Others escaped entirely, becoming dust and debris trailing through the solar system. Such collisions are seldom observed directly. Space is vast, and the asteroid belt is enormous. But here, by chance, Hubble caught one of these violent events in action, a cosmic car crash frozen in time. What these stories show us is that Hubble is not just a telescope for distant galaxies. It is also our witness to the ongoing drama of our own solar system. From asteroids spinning themselves apart, to comets shattered by Jupiter, to storms raging across Saturn, Hubble has brought us closer to these events than we could ever hope to be ourselves. And even though the telescope is approaching 30 years in space, it is still healthy and operational. Current estimates suggest it will remain in service well into the 2030s. Who knows what else it will see between now and then, perhaps another collision, another storm, or another unexpected discovery waiting just beyond our sight. As we reflect on Hubble's legacy, let's remember it has shown us that even in our own cosmic backyard, the universe is alive with change, violence, and beauty, and thanks to its unblinking eye, we've had the privilege to witness it. Thank you for joining us on this journey through the solar system with Hubble as our guide. These snapshots remind us that space is not empty, or still it is alive with movement, change, and extraordinary events happening right now. If you enjoyed this exploration, don't forget to subscribe to Cosmic Compass so you can travel with us through more stories of space and astronomy. Share this video with someone you know who loves the cosmos, and let's keep building a community of explorers together. Until next time, keep looking up, because the universe always has more to show us.